Number 7. Use an appropriate procedure to show that x minus 4 is a factor of the function f of x equals 2x cubed minus 5x squared minus 11x minus 4. If all we're trying to do is prove or show that x minus 4 is a factor of the larger polynomial, I'm going to use the remainder theorem. I'm going to take x minus 4, set it equal to 0, and solve. X equals 4. All I need to prove is that this is one of my zeros. So if I take the function f of x, and I now input the value of 4, 2 times 4 cubed minus 5 times 4 squared minus 11 times 4 minus 4. If this gives me a result of 0, f of 4 equals 0, then this is a factor. How do I explain my answer? Remember, explain means I have to use words of some sort. Because f of 4 equals 0, the remainder theorem tells me that x minus 4 is a factor. The key in my explanation, stating that I used the remainder theorem. Number 8. Solve algebraically for all values of x. I have a radical equation. Immediately I recognize that my radical is not isolated. I need to do that. I need to subtract x from each side. Square root of x minus 5 equals, and I'm going to write this as 7 minus x. My radical is isolated. I need to square each side of my equation. The squaring and square rooting, those are inverse operations. They cancel one another out. On the other side, it's definitely going to be helpful to write this binomial out. 7 minus x times 7 minus x. X minus 5 equals 49 minus 7x minus 7x plus x squared. (49 minus 14x plus x squared). Well, I recognize now that I have a quadratic equation. So I'm going to set my quadratic equal to 0. I'm going to subtract x and add 5 to each side. I now have x squared minus 15x plus 54 equals 0. To solve this quadratic, I have a lot of options. The first one I always try is factoring it. Can I think of two values that would multiply to be 54 and combine to be negative 15? X minus 9 times x minus 6. I'm going to set each of these factors equal to 0 and now solve.